we are looking into the future installation. We are trying to conceptualize, design, build an installation that would be safe, environmentally compliant, energy efficient, well located and suited for the surrounding community and environment, and more important than anything else, less expensive to operate and run.
The Army identifies training as an enduring requirement regardless of where the technology goes. Despite all the advances that we've made in virtual and gaming technologies for training, live training will always be a key component that brings it all together. So from that perspective, these training lands are important to us now, they'll be important to us in the near future, and they'll be important for us longer than that.
There's an ammunition depot in Alabama. The Army's been there for many decades, and there's a contaminant in the groundwater. There's a species of fish that lives in an impounded area, and it only lives there. It doesn't live anywhere else in the country, and it's being exposed to TCE coming out of the groundwater. We got involved on behalf of the Army to say, not only is the level they're being exposed to okay, they can actually be tolerant of a much higher level. So that's an example of kind of a site-specific case where we can provide data for not only the Army, but also the regulatory community in ensuring that installations stay open and that training continues.
Our bases are no longer out in the middle of nowhere. When many of them were first established, there was nothing around them for miles and miles, and now we have urbanization around the fence line of every single Army base that we have in the US. And so we have to learn to work together with them and integrate into that urban landscape. Neighbors don't appreciate loud noises in the middle of the night or smoke or dust encompassing their backyard on a beautiful Saturday afternoon. So ERDC has a whole noise team, or acoustical engineers, that help solve these problems. They have monitors that they can install to understand what noise is generated and under what weather conditions. So if it's cloudy, that can certainly hold in the noise or the dust or the smoke, and wind patterns can blow it where you want it to go or where you don't want it to go. The real challenge boils down to being able to integrate into these neighboring communities in the surrounding area, that you're able to have a positive impact environmentally, socially, and financially.
One of the concepts for future operations is forward deployed environments. These types of technologies are very important in protecting those, what we call projection nodes, and that's how the military, both the Army, Air Force, Marine Corps, and Navy, would move into an environment. The military doesn't always have the engineering expertise that they need downrange. They can't calculate dynamic effects of structures, so we do all that here at the research lab. We understand the weapons effects on these structures, we engineer all of that into the structure, and then we deliver kitted components so that all they have to do is assemble them in their austere environments.
The research that we do here is basically to support the warfighter in the nation against terrorist threat activities, whether it be government buildings here in the U.S. or Army facilities nationwide or overseas. Our customers will give us a specific threat level, and we will dial that into our blast load simulator that's housed underground, and then we will subject our different materials, like for instance the one behind me, which is a reinforced concrete panel, that we're seeing what the response is to that particular air blast pressure and impulse combination. We have the ability to test and evaluate those things here, much more efficient, economical fashion than if you were at a high explosive test site.
Our shake table is for vibration testing, and it was originally built for shock testing. Our table is capable of very high forces and high frequency. This provides the ability to test very massive equipment specimens. So we've tested, for example, generators that are 3 megawatt generators with fuel tanks weighing about 150,000 pounds altogether. So our lab is uniquely able to test heavy equipment like that. So we're the only table in the country that can test something weighing more than 30,000 pounds.
The reason why we do these on supercomputers and not like your laptop is that we have really large problems to solve, and sometimes we have simple problems we have to solve very, very fast. And so we can run these simulations on supercomputers millions and millions and millions of times. Things that would take millions of years for a laptop to solve. The advantages of being able to run simulations like we do on these supercomputers is that we can run hundreds and thousands of these simulations over and over again with different environments, different conditions to see the effectiveness of the work. It's sort of like similar to that Tom Cruise movie where he dies, shows up again, fights aliens, he gets killed, dies again. And, we can do that millions of times when soldiers don't have to die. We can do this all in simulation and provide really good answers from Department of Defense.
The Army Corps of Engineers has had the mission for building military installations since World War II. And so the ERDC has been helping think about installations and how they support the soldiers in their training and readiness mission. But we also have to do that with the environment. How do we make them more energy efficient? How do we support new technology? How do we make them cyber secure? How do we help them do the kind of training they have to do to prepare for the missions that they're going to be facing in the future? That's what we're doing.